Assalamualaikum. Thanks to Miss Hazlin, our chemistry lecture. We're from class 15. We'd like to present about chemistry of perfume. Before we continue, I would like to introduce our group members. Without further ado, let us start. The history of perfume. The art of making perfume, which are known as perfumery, began in ancient Mesopotamia and Egypt. It was discovered by a woman named Taputi. In the 19th century, an Arab chemist wrote a book called Book of the Chemistry of Perfume and Distillation, which had more than 100 recipes for making fragrance oil, aromatic water, and substitute of costly drugs.
The process of extracting oils from flowers through distillation was introduced by the Persian chemist Ibn Sina. First, he experimented with distillation with the rose. Perfumes were primarily used to mask body odors by the wealthy part of the society between the 16th and 17th century. Due to this patronage, the perfume industry got developed.
Main chemicals of perfume. 1. Perfume or fragrant oils. There are two types: synthetic oil or fragrance taken out of specific sources by methods such as headspace. Headspace vacuum the smell directly from the object and recreates the smell by getting a printout of its chemical equation. Oils are extracted from flowers, plants, animals, or other natural resources. The chemical equation for perfume oil are dependent completely upon what the oil was taken from.
Second main chemical of perfume are water and alcohol. There are many types of alcohol that can be used in perfume making, but ethyl alcohol C2H6O is most commonly used as it helps the fragrance to spread out. Distilled water H2O is also used in fragrance for spreading out the smell of the fragrance. Based on the amount of dilution added, there is a much different strength of perfume.
These are some of the ingredients that are used in perfume making. First of all is alcohol, which is the main component of perfumes. It modifies the fragrance intensity and makes the application on skin easier. Secondly, we have aldehydes, which is an essential class of perfume ingredient that impart a vivid top note of the perfume. Next one is balsam, which is a resinous material obtained from trees which give a combined sweet woody odor associated. The next one is musk. The original musk is obtained from the pouch found between the rear legs of the male musk deer that has now been replaced by the use of synthetic musk. The next one is eugenol, which is a powerful spicy odor of clove found in oils of cloves and cinnamon leaf. Next, we have hydroxyl citronella, which is a beautiful lily aromatic. It is widely used in perfumery. Lastly, we have rhizomes. Rhizome is a root-like stem with note which grow under or along the ground, where it was used for the face powder or perfume sachet. These are some of the chemistry roles in making of perfumes. A smell is a molecule that is light enough to float in the air. Fragrance materials are generally semi-volatile organic compounds. However, not every molecule that floats in the air has smell or has enough smell to be recognized by human nose, which, for example, carbon monoxide. Chemical reactions are caused by light can morph the smell of the perfumes. It is because the energy in light can break the bonds in fragrance molecule. Bright sunlight can destroy the perfume within just a week if it's just being exposed to sunlight without any protection. With that being said, one of the best places to keep your perfume is in a dark room at room temperature in a spray bottle.
Okay, next we'll be moving on to the next topic, and that is why certain molecules have smell and others don't. First, we'll look at the carbon chain. Firstly, carbon chain doesn't have strong dipole moment. Secondly, when there is two carbon chains, there is only a little of London disperse force occurred between the carbon chains. Thirdly, that made nothing keeping the carbon chains together, causing it to evaporate vastly. For that occurrence, in which it has a high vapor pressure and no existence of hydrogen bond, is the reason why it has a strong smell. As we look at the diagram at the next of the text, this is the molecule structure of lemon. See at the diagram, it is shown that this structure of lemon have a small chain of London dispersed force, making them very fast evaporate. This occurrence causing them to have a very strong smell, such as the smell of oranges and lemon. Next, we will move to the next slides and we'll be looking at a water molecule. Contrary with carbon change, water molecule doesn't have a very strong smell. This is because water molecule has strong dipole moment, which means has a partial positively charged hydrogens and partial negatively charged of oxygen. There are two bonds that are happening, and those are valent bond within the molecule and a hydrogen bond connecting with other water molecules. For that fact, water molecule has a very strong network, making it stay in liquid form. Contrast to carbon change, it doesn't evaporate fast and doesn't make it have a very strong smell, as it's shown at the diagram on the next stats. This is an example of hydrogen bonding between partial negatively charged of oxygen and positively charged of hydrogen atom.
The reason perfume is made in a wide range is because body chemistry plays a huge role in how fragrance perform on the skin. Each individual has a different body chemistry. For instance, every person has a different body odor. Fragrance usually lasts longer on a moist skin compared to a dry skin, and that's the reason there is summer and winter perfume. It is usually recommended to apply perfume on the pass point because the heat generated from the pass point have to diffuse, magnify and amplify itself.
Another factor that determines the longevity of the fragrance is the molecule of perfume. The size of molecule and smell are correlated because the size of molecules determine how fast it oxidizes. The smaller molecules, such as light citrus aroma, oxidizes quickly. And for example, the molecule of a mask is complex and has a lot of electrons to give away before it disappears. The molecules of some synthetic masks are so large and complex that they literally can last days on your skin. And that's all from us. Thank you for your time and patience.